Example 4. A function g of x is given as a graph below. Find g of 3 and g inverse of 3. To evaluate g of 3, we find 3 on the horizontal axis and find the corresponding output value on the vertical axis. The point 3, 1 tells us that g of 3 equals 1. To evaluate g inverse of 3, recall that by definition, g inverse of 3 means g of x equals 3. By looking for the output value 3 on the vertical axis, we find the point 5, 3 on the graph, which means g of 5 equals 3. So by definition, g inverse of 3 equals 5. Try it now. Using the graph in example 4 above, find g inverse of 1, estimate g inverse of 4. Example 5. Returning to our designer's assistant, find a formula for the inverse function that gives Fahrenheit temperature given a Celsius temperature. A quick Google search would find the inverse function, but alternatively, Betty might look back at how she solved for the Fahrenheit temperature for a specific Celsius value and repeat the process in general. C equals 5/9 times F minus 32. C times 9/5 equals F minus 32. F equals 9/5 C plus 32. By solving in general, we have uncovered the inverse function. If C equals h of f equals 5/9 times f minus 32, then f equals h inverse of c equals 9/5 c plus 32. In this case, we introduced a function h to represent the conversion since the input and output variables are descriptive, and writing c inverse could get confusing. It is important to note that not all functions will have an inverse function. Since the inverse f of x takes an output of f and returns an input of f, in order for f inverse to be itself a function, then each output of f, input to f inverse, must correspond to exactly one input of f, output of f inverse, in order for f inverse to be a function. You might recall that this is the definition of a one-to-one function. Properties of inverses. In order for a function to have an inverse, it must be a one-to-one function. In some cases, it is desirable to have an inverse for a function even though the function is not one-to-one. In those cases, we often limit the domain of the original function to an interval on which the function is one-to-one. Then find an inverse only on that interval. If you have not already done so, go back to the toolkit functions that were not one-to-one and limit or restrict the domain of the original function so that it is one-to-one. If you are not sure how to do this, proceed to example 6. Example 6. The quadratic function h of x equals x squared is not one-to-one. Find a domain on which this function is one-to-one and find the inverse on that domain. We can limit the domain to, close parentheses, 0, infinity, open parentheses, to restrict the graph to a portion that is one-to-one, and find an inverse on this limited domain. You may have already guessed that since we undo a square with the square root, the inverse of h of x equals x squared on this domain is h inverse of x equals the square root of x. You can also solve for the inverse function algebraically. If h of x equals x squared, we can introduce the variable y to represent the output values, allowing us to write y equals x squared. To find the inverse, we solve for the input variable. To solve for x, we take the square root of each side. Square root of y equals the square root of x squared, and get square root of y equals absolute value of x, so x equals plus or minus the square root of y. We have restricted x to being non-negative, so we'll use the positive square root. X equals square root y, or h inverse of y equals the square root of y. In cases like this, where the variables are not descriptive, it is common to see the inverse function rewritten with the variable x. H inverse of x equals the square root of x. Rewriting the inverse using the variable x is often required for graphing inverse functions using calculators or computers. Note that the domain and range of the square root function do correspond with the range and domain of the quadratic function on the limited domain. In fact, if we graph h of x on the restricted domain and h inverse of x on the same axes, we can notice symmetry. The graph of h inverse of x is the graph of h of x reflected over the line y equals x. Example 7. Given the graph of f of x shown, sketch a graph of f inverse of x. This is a one-to-one function, so we will be able to sketch an inverse. Note that the graph shown has an apparent domain of 0, infinity, and range of negative infinity, infinity. So the inverse will have a domain of negative infinity, infinity, and a range of 0, infinity. Reflecting this graph of the line y equals x, the point 1, 0 reflects to 0, 1, and the point 4, 2 reflects to 2, 4. Sketching the inverse on the same axes as the original graph.